Good morning, guys. Welcome to today's lesson, May 15th, factoring review. Really just going to take a look at all the different types of factoring. When we look at a problem, we have to be able to determine what method should we be using. And let's think about all the methods that we've learned so far. GCF, dots, AM, AC, and grouping. And remember which one we always check for first. All right, that's GCF. So 5 questions today. I would pause the video, try them all on your own first. All right, and then you can watch this and you can see how you did. So identify the method and factor each expression completely. So you have x squared minus 25. Check for a GCF. Is there something that divides both into x squared and 25? The answer is no. So check GCF first. Nope. All right, next check dots. Okay, would this be an example of dots, a difference of 2 perfect squares? All right, and the answer is yeah. All right, it's 2 perfect squares. And remember what your perfect squares are. All right, perfect squares are 1, 4, 9, 16, 25, 36. All right, and you could see 25. That's a perfect square. All right, and it can be for variables as well. Really anything to the second power and then even from there. So what I mean by that, x squared, x to the 4th, x to the 6th, x to the 8th, and so on and so forth. Another perfect square, because x times x, right, x times itself, gives you x squared. So those are both perfect squares. So the method we're going to be using is dots, difference of 2 squares. So what times itself gives us x squared? We said that's x. What times itself gives us 25, and that's 5. So we separate it into 2 binomials with x and x, and 5 and 5. And remember, for dots, when you factor that, you're going to have one addition sign and one subtraction sign. Now, are we done? Is there any other way that we could factor this further? Maybe a sneaky GCF, and the answer is no. All right, and you're done. A simple version of dots. Okay, but remember what you're looking out for when you have dots. Why was this dots? Because it's, first off, it's a binomial, 2 terms. It's subtraction, right? Difference is subtraction. And they're both perfect squares. So that's what dots is. And when we use it, make sure you check for GCF, however, first, which we didn't have. All right, next one. X squared minus 2x minus 8. So it's not going to be dots to start, but even further, even thinking before that, we got to think GCF. Would this be an example of GCF factoring? All right. No, there's no GCF here. Okay, we can't divide all 3 of those terms by the same thing. Is it dots? Nope, because it's 3 terms. It's a trinomial. All right, is it AM? Well, since it's a trinomial, it's going to be AM or AC. Since the value in front of x squared is 1, that tells us we're going to have AM factoring, where we need 2 numbers that are going to add to -2 and multiply to -8. All right? So what are those 2 values that are going to multiply to -8 and add to -2? This would be -4 and 2, because -4 times 2, that does give you -8. And how about when we add them together? That gives us -2. All right. So open up your parentheses again. It's going to be 2 binomials. It's -4 and +2. And remember, when it's AM, what we put in front there, just a plain old X in both locations. Are we done? The answer is yes. Okay, how could we check our work? Remember, we could use the box method. All right, just multiply it out, see if it gives you the original. Or you could put the original and the factored form, put both of them into GeoGebra. You'll see it'll give you the same graph. All right. So AM factoring there. Next, 5x squared plus 11x plus 2. Is this an example of GCF? Is there a common factor? Is there something we can divide into all 3 of those terms? The answer is no. All right, is it dots? Definitely not. Is it AM? No, it's actually AC this time, because the value in front of x squared is 5, which is bigger than 1. All right, remember this was factoring a trinomial when a is greater than 1. All right, so AC, a times c, is equal to 5 times 2, which is equal to 10. So the two numbers have to multiply to 10 and add to the b value, the value in front of x, which is 11. So what multiplies to 10 and adds to 11? Multiplies to 10, adds to 11. That would be 10 and 1. Right? 10 times 1 is 10. 10 plus 1 is 11. Okay? So your two binomials, again, open those parentheses up. We have a positive 10 and a positive 1. What do we throw in front here? Not x. When it's AC factoring, we need that a value. That a value is 5. So 5x, 5x. Okay? And now we check, can we divide something out? All right, 5x plus 1, you can't divide anything out. But 5x plus 10, you definitely can. We could divide both of these by 5. Now the 5, like normal GCF factoring, the 5 does not get tossed out front. We just divide 5x divided by 5 is x. 10 divided by 5 is 2. So we have x plus 2. And you keep that 5x plus 1. Remember, once again, you could check your answer. Okay? Box method, GeoGebra, whatever. But I want to remind you of the quick check. Is x times 5x 5x squared? Sure is. Is 2 times 1 equal to 2? Sure is. So that's a quick check. That's not a perfect. It's not always going to work, but most of the time it will. Alright, so we end up with x plus 2 times 5x plus 1. Alright, 4 here. Alright, now we have 4 terms. Okay, doesn't matter, GCF, check for GCF first. Can we divide all these by the same thing? Is there a number that goes into 5, 10, 3, and 6? There is not. No common factor besides 1. Now, guys, this is 4 terms now. Alright, so if it's 4 terms, that means we're going to factor by grouping. Remember how we do that. Alright, you might have to go back and look at that video from a couple days ago, factoring by grouping. But we split it up into 2 groups. First 2 terms and the next 2 terms. Remember, we find a GCF for each group. Okay, so the GCF for the first group is what? 5x cubed plus 10x squared. Between 5 and 10, what's the GCF between 5 and 10? That would be 5. And also, what's the GCF between x to the third and x squared? All right, they both have x squared in common, so we have a GCF of 5x squared. So divide both of these by 5x squared. This is now true GCF factoring, so the 5x squared gets thrown out front of the parentheses. Okay, 5x cubed divided by 5x squared is just x to the first power. Now 10x squared divided by 5x squared is just 2, so plus 2. All right, now let's work with the next group, 3x plus 6. What's the GCF for 3x plus 6? We can divide both of those by 3, right? No x, though, because 6 doesn't have an x. All right, so we can divide both of these by 3. The GCF goes out front, so plus 3. Open up your parentheses. 3x divided by 3 is just x. 6 divided by 3 is 2, so plus 2. And we're almost done. Notice how in both sets of parentheses we have the x plus 2. So one set of parentheses in your final answer gets those GCFs, so 5x squared plus 3. And the next set of parentheses gets that common expression that's in parentheses, which is x plus 2. And you are done. Okay, so remember when we use grouping? That's when it's 4 terms. All right, we didn't have a GCF for all 4 terms, but when we broke it up into 2 groups, each group, all right, each respective group had its own GCF. So we divide out a GCF for each group. All right. And one more. All right, we have x to the 4th plus 6x to the 3rd plus 5x squared. What type of factoring would this be? All right, remember, we're always checking for GCF first. Can we divide something out for all 3 of these values? Actually, we can. You see how they all have an x in common? And not only do they have an x in common, they at least, each term has at least an x squared. So we can divide out an x squared from each of these terms. So divide by x squared. X squared goes out front of the parentheses now. So we have a GCF here. X to the 4th divided by x squared is x squared. 6x to the 3rd divided by x squared. Right, so that would be plus 6x. And 5x squared divided by x squared is just 5. All right, so we divide out a GCF. Each term had something, a common factor we could divide out. Now be careful, we're not done. In these parentheses, look at that. That's a nice trinomial that can be factored. Would it be AM or would it be AC? What's in front of x squared? Just a 1. So this is just your standard AM factoring. Now you still have the x squared in front, but now we're going to have 2 sets of parentheses when we factor using AM. So factors of 5 that add to 6 is just 5, right, positive and positive 1. And what goes in front of each of those? Just your plain old x when we're dealing with AM factoring. And now you're done. So this was a combo. All right, it was GCF and AM factoring. Factor completely. Generally, guys, you're going to factor completely. The directions really don't even need to tell you that. Okay, if you see an opportunity to keep factoring, go with it. Okay, so we kind of looked at all the different kinds of factoring, guys. GCF and AM. All right, grouping for 4 terms. AC for a trinomial when A is greater than 1. AM, that's a trinomial when A is equal to 1. All right, and dots. All right, guys, please ask questions and remind if you have them at all. Your remind is still open, okay, for most of the credit. So if you forgot to, your Delta Math rather, all right, if you forgot to do your Delta Math, please complete that. All right, and that's really it. Have a wonderful weekend, and I'll see you on Monday.